without surprises. This talk will hopefully change the way you think about error handling in TypeScript. We are going to use the effect library and see how it solves problems you might not even realize you have. My name is Nir Tamir. I've been doing front-end for over a decade. You can find more about me at nirtamir.com. So TypeScript is great. It helps us catch errors before they happen. For example, if we have a function that expects a number and we pass it a string, we get a compile time error. And when we fix the error, we get the return type automatically. TypeScript infers the return type. This makes composition easier and refactoring safe. But in real-world apps, we hit some edge cases the type system can't handle. For example, divided by 0 returns infinity. It's a valid number, so TypeScript accepts it, but it's probably not what we want. So we can use try-catch and throw an error, but notice, the error type is unknown. TypeScript doesn't know what the error is exactly. So we have to manually check its shape in order to handle it. And look at this function, make coffee. TypeScript helps us with the parameters. We know that this function accepts no parameters, and it returns a coffee. But when we actually run this function, we get a machine out of water error. TypeScript didn't tell us that this function can throw. So how do we actually handle errors that we can't see? It reminds me the days before TypeScript, in the JavaScript days. We didn't know what function expects and what it returns. We had to look at the function implementation in order to see what's happening there. And null and undefined, they were everywhere. I don't miss those days, but TypeScript solved this problem. Now we know what a function expects, what are the parameters, and what it returns. But when it comes to errors, we are alone. The TypeScript compiler won't help us with this, because the errors in TypeScript are unknown. So how do we handle errors today? So we can create a custom class that extends an error with a tag, so we can identify it later. And if we will throw this exception, we can throw this custom exception. And inside the try-catch, the error type is still unknown, but we can we can check the type with instance of and get inference inside the error instance of custom error. We can also do what Go language does. Go doesn't have a throw in the language, and we can use errors as values. So we can do the same things in TypeScript. In this example, I created a result type that either gets the data or the error, but not both. And if we can return the error in case of an error, or we can return the data. So it's returning errors as values. And then the TypeScript can infer the result type automatically. It knows that inside the result.error equals null, we get the data of string, and outside of the if block in the else, we get the custom error. But these things get messy because we need to unwrap and wrap everything. So we have a lot of repeated code, like checking if the error is null or not. And if you are writing a Go function, if you are a Go developer, this is probably familiar. You are probably familiar with this. You have to check error all the time. So TypeScript is great for the happy path. When we are in the happy path, the compilers help us with the return values. But when we are throwing in errors, we have some problems. So what we really need is errors in the type system. So the compiler will help us with this. And this is where Effect comes in. Effect is a powerful TypeScript library that helps you with defining errors as part of the type system. And it does much more. Let's start with the effect type. It accepts 3 generics: success, errors, and dependencies. So success is like the return type in TypeScript. When everything goes right, this is the return value. Error is if things go wrong, this is what it returns. And requirements are the dependencies that require in order to run this function. Very similar to promise resolve and promise reject, we have effect.succeed and effect.fail. In this example, we created an effect with effect.succeed of 42. So it means, like promise resolve, this is a new effect that succeeds with the number of 42. So the type is going to be effect of number, never, never, because it never fails. And we can also define an effect using effect.fail of the value oops. So the type is effect of never, because it never succeeds, string, which is the error, and never has the dependencies. Effects are like blueprints. So when you create effects, you don't run it yet, nothing executed yet. We have to run sync or run promise. Those are methods that effect provide us in order to execute the effect. So let's create a real example. I started with creating a payment failed error that extends data.tagged error with the string of payment failed. This comes from effect, very similar to our custom error in the previous example. And inside the program, we can create effect using effect.gen. Effect.gen is a way to create effects, but it accepts the generator. So we have to write function asterisk. Inside this function, we have a logic that if credit exceeded, we return yield asterisk of effect.fail with this error. Yield asterisk is a way to tell effect that we are going to fail with this value. It also unwraps the effect value. So if we have effect of the payment failed, it gets the payment failed without the effect. And if everything goes right, we return the payment ID. But notice, now effect is aware of the failure. So the type of the program is effect of string, which is the return value if everything goes right, and payment failed when things go wrong. So effect is aware of this failure. We can't forget it. So if we run this function, it's still going to fail because we didn't handle the error, but we still have it in the type. What we can do with effect is to pipe effect.catchTag. Because effect is aware of the type, it knows that we are going to handle a payment fail. So payment failed is something TypeScript auto-completes. And then we can recover from the error by saying that if payment failed, so it's on the house. So we don't fail. And when we execute this function, first we can notice that the effect type is now of a string never, never, so it's not going to fail. And when we will execute this function, it's safe. We are going to return a string because all the errors are handled. So the key point is that with effect, the type guides us. Before the effect, we have a string of payment failed never. And after we handle it, we get a string with no option to fail. All errors are handled, and we know it by the TypeScript compiler. Real programs have many failures. Network error, validation error, database error, a lot of errors. We can handle them with effect also. So in this example, I created a network error and validation error. And inside the effect, some functions, validate user, might fail with validation error, and send to server might fail with network error. Those functions are functions that my colleague wrote. They could throw exceptions, but we don't look at the implementation. We know that they can fail with those validation error or network error by the type itself. And effect is aware of it, so the program type is effect of user, network error, effect of user, network error, or validation error. So those failures bubble up. We can also handle them using effect.catchTag. So for network error, we can recover with a cached user. And for validation error, we can transform the error to a different type of error, of bad request error. And effect is aware of it, like TypeScript inference. So it knows the return type is effect of user, bad request error, and never. So network error and validation error are handled already. We only left with bad request error. So you're probably familiar with such code, regular TypeScript code, and each operation might fail and throw in a way that we are not expecting, And when we write the same example with effect, so the syntax is a little bit weird because we are using generators and we are not used to write generators, but at least we know that for every line, we know what is the type of the effect and what can fail. And eventually, we get, for this program, effect of data, fetch error, or parse error, or save error. So we can't forget them. So this is the key difference. The syntax looks a little bit different, but it's basically the same. So the key point is that we can use the type system to track errors, not only success values. And when we can track the errors, we can actually handle them because we see them instead of throwing generic exceptions everywhere. So we talk about how effects allow us to track errors, but we can also do more things with effect. We can recover from errors, retry them, and compose effects in many ways. Effect provides a lot of functions, very similar to Lodash. You have a lot of functions in effects. I don't know half of them, but they are here to help us with more complex use cases. So let's see an example. We can use effect.timeout, and we pass it an effect and a timeout, and it adds a time limit to the effect, failing with the timeout if the timeout is exceeded. So if, for example, we order pizza and we want it to be fast, and if it's not fast, we want it to fail. We can also run an effect repeatedly until it succeeds, ignoring the errors, using effect.eventually. Okay. We can also retry an effect with a fixed number of times. So we can use the scheduler from effect, and we can retry it 4 times with a space time of 2 seconds, just with the composition. And we run it again. We can also retry with exponential backoff. So it means it will try to execute the effect with spaced repetition, but with exponential. So we start with 700 milliseconds, then it doubles the time that it retries. In Vercel, they have problems with auto-renewing the domains feature. And they started with 3 errors of API errors, Stripe payment errors, and Stripe payment method errors. But after they use effect and never throw, which has a similar concept, they end up with 17 errors. So it looks a little bit weird at first because we have more errors, but now we know what we have. And when we know what errors a function can return, we can actually handle them. And also give the users a lot of context, and also recover from some of them or retry. So the key takeaways is that TypeScript is great for the happy path. When everything goes right, TypeScript guides us perfectly. But errors are invisibles in normal TypeScript. We don't know when a function can throw and what happens when it throws. So effect can make your errors visible. And when you have more specific errors, it leads to more reliable code because we actually handle what's happening there. Thank you very much. You can find the slides in my website. And if you have any questions, you can find me after the talk at Nir Tamir. You can find me here, ask questions, or at nirtamir.com. And the slides are available.